That one's recording. That one's recording. Are you recording?
I am, yeah.
Let's do it.
Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hi, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 111. Today we're talking about 3D graphics that have gone ultrasonic, lobotomizing Alexa, 3D printing leaky rockets, and gaming the font system. Elliot, my thing about optical media for gaming systems is coming to fruition because Sony has announced that they're shutting down the game download servers for PlayStation 3.
And what happens then?
Well, if you don't have a game on your hard drive that you've purchased digitally, you're never going to ever be able to get it again unless you repurchase it, I guess, on a different system. The interesting thing about this is that because of the DRM, which is digital rights management, that they built into the system, there is a clock synchronization check that gets reset if you change the battery that's internal to the PlayStation 3, or if it dies, this clock gets reset and then it needs to phone home to the PlayStation servers to re-up. And so I get the feeling, I haven't fully confirmed this yet, but the reporting that's coming out of this sounds like that server check is going to be gone too. So even if you have the game already on your drive, if you need to change the battery or it dies and these servers aren't running, you won't be able to play those games.
That is not nice, even though you purchased them.
Yeah.
They can just take away something that you bought. This is total fake indignation on my part. Like, I know that Sony wants you to buy all media 2 times, 3 times, 4 times because they get paid every time you buy it.
I've done that on some things, just for the convenience of it, like some games that were really old and I wanted to play them on PS4 and, PS4 is not backward compatible. And so I bought it again and played it again. And that was fine because I made that choice. But I think it's different when you've retained physical media because you're going to want to pull this thing out someday and play it again. I have this fantasy that in retirement, I'm going to be living in the old folks' home playing awesome multiplayer games from the early 2000s.
With your sweet, sweet CD-ROMs.
Yeah, I know. The lens on that CD-ROM player might have something different to say about it. But
no, I bet it'll work.
Well, I guess then the power supplies will be shot and need a recap.
By then, you'll just be able to take a picture of it, and your camera will have enough resolution that you can just read all the bits off the CD-ROM anyway. Somebody will have an app for that.
I think you just buy a new PlayStation 3 in your VR world that you're living in. At any rate, I will likely, before July when this shuts down, crack my PS3 open and change that battery just to hedge for the future. It's been sitting in my basement forever, for years and years, and I keep meaning to hook it up to my exercise machine because I'm I would exercise way more if I was video gaming while I was exercising. At any rate, this article that Drew wrote has links to a guide on how to swap out that battery for a fresh one.
I wonder if that really means that it's time to start man-in-the-middling that time server while it's still running and see if we can spoof it. Because if the only problem is that it doesn't get the time, then see what the time server says when it asks and then get ready to say that to it again in the future.
Oh, that would be fantastic. I did see someone in the comments of this article said if you live in the EU and the manufacturer of the machine gives you no other way to access these games, then it's all bets are off. You can crack the hardware, software, whatever you need to do to play those things that you rightfully purchased.
I believe there's a DMCA exemption for that too.
Really?
I am not a lawyer and I don't live in the States, so don't come knocking on my door, but I think that is true. We pulled out my wife's PS1 a while ago and tried to plug that in, and it was really fun to play, I guess, Final Fantasy VII on the original hardware and original low resolution, except the machine is so old that after playing for a while it gets this green tinge. The red channel on the DAC starts to fade or something. It's an old machine and it's on crutches.
I thought that was a PS1 game.
If it's a PS1 game, then we have a PS1.
It is PS1.
Because we were definitely playing Final Fantasy VII.
1997, Elliot.
Tell you what.
That was a fantastic game. Do you remember that, there was a special, finishing moves or whatever with the swords, and there was one where you could cast your sword up in the sky and harness a planet and through gravity bring it down upon your enemy? and it took like 40 seconds for this animation to play in the middle of these battles.
I didn't get that far, actually. I shouldn't admit this. I've never played Final Fantasy VII until last year.
Oh,
Until
well,
2020.
kiss a number of months away of your life, because that one's worth sitting in a beanbag chair and really grinding on it.
Oh, not until we fix those capacitors and the colors stay right.
This is an excellent week of hacks, and we have to start with the video game that you can play as a font. This is completely bonkers, but an open type font file can be loaded onto your computer, and then you can open up whatever program you want, choose that font, and start typing. And instead of the letters, ABC, you will see a little like Game Boy size grayscale image of a video game, kind of a Pokemon clone type of game, start up, and you can just go along playing on whatever program you want.
Crazy.
This is the work of Michael Moulet, who decided to take this on and see how far the rabbit hole goes. And it goes really, 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 really deep. He chose the type 2 char strings because they give you the ability to write glyphs as if you're like, I think someone in the comments referred to it as like the turtle script that they used to have. You can kind of like map out where the thing's going to go.
Yeah, you go up, over, left, down.
And the best part is you write these in reverse Polish notation. I actually downloaded. Did you play with this at all, Elliot?
I didn't, no.
Yeah, I downloaded it and played it. I had trouble getting it to run on LibreOffice Writer. Like it would cut off the top third, or the top third of the frame wouldn't refresh or something like that. But I had no problem in GIMP. And it's funny because you can like hold down a letter and it'll advance through the frames really quickly, and you like try and read to keep up with it or whatever. But eventually it'll ask you to make a choice. And then I wasn't holding down the right key, and it'll be like, oh no, you made the wrong choice and we can't move forward unless you make a correct choice. And then it's like you have to press the backspace key. So if you backspace, it like rewinds the game that you've been playing. So like if you're battling an enemy and you don't like the outcome, you can just like backspace your way and make different choices. It's like a read your own adventure where they counted on you being honest on flipping to one choice and not like reading the two choices and deciding that way.
Yeah. It can't do any calculations particularly, but it can take these branches. And so you can make like nearly 5,000 individual frames inside a font. And then he's somehow limited to 131 branches from 43 distinct choices. And so I guess that's how many different paths through this kind of, you said, choose your own adventure, which I think is basically right, you can go in this game. Do you have any idea how the heck he did it?
Well, so you have to kind of get over the like how they're drawing and combining frames. Like I think that's the really confusing part of it. But once you get to flow control, I mean, it's just subroutines. It's pretty easy from there. So once you figure out how you're going to draw these frames, you can just wrap that in a subroutine and then do your normal programming flow from there. That's pretty straightforward.
Because it wants to use a subroutine like thing for drawing, the graphics in the logo turtle like language. Then you can use these to do something else.
Yeah, you might have the same glyph used in a bunch of different characters in a language, and so you can subroutine that glyph.
Okay, well, that makes a lot of sense then, actually.
The crazy thing for me is this whole thing is only 998.9 kilobytes, which doesn't seem that long. I mean, everything's in the file, right? But I suppose, I don't know, that seems small. Under 1 megabyte.
I was going to say, that's huge. That's a megabyte.
Yeah, how big are fonts usually? I have no idea.
I don't know either.
When I measure my hard drives in multiple terabytes, I never consider how big a font is before I install it. That's probably a security vulnerability. Why is this font file a gigabyte? What else could be in there? Other than
what's going on here? Oh, it's a choose your own adventure game.
The clever thing here is you might be on a system where you're restricted from installing programs, but you're not restricted from installing fonts. And so this could be your end run around doldrums stuck in the toll booth on the turnpike. And you could be playing this game on your logging software if you just install a font file. So go forth and do shenanigans.
All right, my first hack this week is a doozy. Andre Henschel has taken apart an Amazon Echo and reflashed it to give the Amazon Echo an open source brain transplant. And this is really awesome. If you have an Echo or any of these, devices that phone home to the cloud to hear what you're talking about, you might want them to do that locally. There's no reason they shouldn't. You have a computer in your home. He doesn't have the code up yet, so this isn't a just I'm going to copy this and flash it in, but he does detail all of the steps he took and point at the different libraries and tools he's using along the way. So even though this isn't like a plug and play replicate this hack, it definitely shows you a lot about how you could do it yourself. And that's what I loved about this. He starts with kind of the pin out of the debug port on the bottom of the thing, and then a way to solder in an SD card to these debugging pins. I guess he uses a nice little 3D printed pogo pin jig to then put an SD card into this thing, and it will run software off that. And so that's how he can get his own version of Linux running on the Amazon Echo. And that by itself is actually friggin' awesome. So this whole bit with getting Linux onto your Echo actually comes from an old post from F-Secure, Alexa, Are You Listening? And an even older paper from Cook and Clinton. You can find links to these in his write-up. But just getting Linux on the thing isn't enough. Now you need to make it listen to a wake word and then process what you're saying. And he does that almost exactly like Echo does itself, which is to say he uses some software called Porcupine, which unfortunately isn't open source, to listen for a wake word and then shoves the rest of the audio off to another computer on his network, uses voice to JSON, which does the parsing of the text. You actually can slot in your own speech to text engines for this, and so you can use whichever one works best with your language or with your voice or whatever. And then voice to JSON kind of understands it and, says, oh, this person's trying to do something with that light, or they want to turn it on or whatever. The rest of it is coding on your big computer. The pièce de résistance here is the Open LIPC library, which actually had been worked on by some Kindle people. Turns out to have the header files he needed to make that ring light that's at the top of the Echo work. And so put all of these together and you've got a complete, entire working clone of the Echo running on almost all open source software, certainly all free software, and within the confines of your own house.
I mean, that ring light has to be the first thing that you make work if you're trying to roll your own firmware for something like this, right? I mean, what's the first thing you do when you power up a processor is you blink an LED to make sure you got to the finish line.
It's really cool to make your own Amazon Echo clone that works locally, but I think this is going to be even cooler if other hackers start working on what you can do with that mic array. And if that sort of thing tickles your fancy, you have to keep listening till the end of the show because I'm going to keep talking about that in our Can't Miss Hacks later on.
There is a really esoteric display on display this week in the form of 100 ultrasonic transducers being used to move a small bead of styrofoam through 3D space. And it's even lit up with some RGB LEDs. And moves fast enough it reaches something of a persistence of vision effect that lets you draw some patterns in this space. It's really remarkable. And it started off when Dan Foisey looked at a video from several years ago that showed the standing wave example where you would have kind of not quite hemisphere, but cupped arrays pointed up and pointed down at each other of these ultrasonic transducers. If you've seen those ultrasonic distance sensors, it's kind of like the little cans that look like eyeballs on those. You put those in a grid of 10 by 10 in this particular example, and you blast out the same waveform, but it's exactly out of phase with each other. And that creates like these standing pockets in midair, and you can put something that has, a profile that's going to get picked up on that, but is very lightweight. Dan looked at it and thought, I wonder if you can steer that. And so has created what I would say is effectively a phased array of these ultrasonic transducers, a 10 by 10 pointed up and a 10 by 10 pointed down. Each of these has 2 FPGAs that command the 10 by 10 array, and they're able to move incredibly well. There's some like oscillation in it. So if you like move the bead really quickly from one side to the other, it doesn't like stop on a dime. It's got like some backlash to it, but the thing reliably moves at a 1 meter per second, which is an incredible speed for these things.
No, this is a crazy hack, and I don't know if everybody has gone to watch the video for this, but like I tried to pick good images for this one to show off just how mind-blowing this is, and none of them work. You just have to watch the video. So go do that right now, because like Mike said, there's a persistence of vision thing going on here. And as cool as it is to make a levitating styrofoam ball, we've kind of seen that before. Steering it around is one thing. Steering it around synchronized with lights is another. And he makes essentially animations. Like he has this one animation of a butterfly flapping its wings that is entirely convincing. It's entirely in 3D, and he can make it do rainbow colors at the same time. What?
Yeah, and in that video, Dan, right at the beginning, says, jump to 6 minutes and 35 seconds to watch it. You're going to want to do that. But then I guarantee you're going to go back to the beginning and watch the whole thing, or at least that's what I did, and enjoyed it the entire way. One of the most interesting parts for me is that Dan builds a simulator for this, because he's like, I want to see if I think this is actually, if this steering is going to work. Of course it does. It looks wonderful. He actually believes that he can make it move multiple balls in the same space at the same time. It's just a matter of doing the math.
That's going to be trickier. I mean, multiple balls in the same space is easy, but multiple balls doing independent motion in the same space is going to be tricky. Have we featured these before on Hackaday, where people do these like ultrasonic levitators? You can put usually a couple of these little styrofoam pellets vertically oriented up above each other, but then making them move independently is a serious computational trick.
If you really want to dig into this one, there is a dense paper that Dan replicated or picked up and ran with. And this is a paper from 2019. I hadn't seen it before, even though I'd looked at those standing wave examples before. So check out the show notes, hackaday.com/podcast for that.
For a significantly less mind-crushing hack. Actually, a really pleasant hack. In fact, a beautiful, simple introduction to a topic. A crash course on sniffing Bluetooth Low Energy. This is a 3-video series by Stuart Patterson, and he's using the NRF52480 dongle, which is available fairly cheaply, kind of $15 to $20, to snoop on Bluetooth Low Energy communications between a control software that he's got running on his iPad and a smart light bulb that he bought at the $5 store. And it's a really nice overview of not just Bluetooth Low Energy technology, but also using these NRF dongles to capture Bluetooth in their promiscuous mode, and then how to look at it both on a cell phone app to get kind of the top level overview, and then how to dig in further using Wireshark. What's really nice about this is he takes you through from, say, you don't know anything about Bluetooth or Wireshark, and he takes you through to where you can actually be a little bit dangerous with these tools.
I think it's really interesting because there's that like stumbling around in the dark thing that goes along with wireless, and having a tool like this where you can just easily see the monitor, and like he walks through the basics of downloading those tools, setting them up and looking at them. And then even like with the reverse engineering part, he's just like copying data out into Notepad for a whole bunch of samples and explaining what it is. And that to me is probably the most useful, is like a quick start to like getting some, it's printf for wireless.
Yeah, right? Well, I have to say he got hella lucky on this, but you probably will with things like smart light bulbs and simple home appliances as well. So it's always worth a try just to fire them up and see what you get. I guess what I mean by he got lucky is when he's doing the data analysis. So in video 2, he's pulling the data down, saving it, and then running it into Wireshark, filtering on the BLE write requests that he had seen already on the cell phone app, and then looking at what data is inside those. The data format for this light is particularly pleasant. It's like obviously an RGB value for the color when it's, change the color command, and on and off, the numbers it sends are just off 1 bit from each other. So it's pretty obvious just looking at the values that these things are sending, what they're doing. And of course, he's got the benefit of having the control app, so he knows when he pressed the on button and the off button and can correlate it super easily. But if you've never tried to do this sort of thing before, and you do have a particularly easy device like he does, you could totally follow this and you could get it done. And I thought that was really cool. When I say super lucky, I guess I mean there's not like a checksum on the data that you'd have to recalculate every time. There is some kind of magic number at the beginning and the end, but it doesn't seem to change across the commands. So, there's no checksum magic. There's no nothing here. It's just read the numbers, figure out what they mean, send them back, and you've got control. And then finishing it off in video 3, he pulls an ESP32 into the mix, and using the ESP32 BLE Arduino client example sketch, like one of the blink me's of the BLE Arduino world, he then tosses in his new data, has it discover the device, and then spit out data to it, and he can randomly change the colors of his light using an ESP32, which I thought was a really sweet demo. But it also shows you, kind of all those funny little steps you have to go to, like how to find the light, which is saying it's advertising that it has this service. Anyway, if you are new to BLE or new to simple protocol sniffing, listening, reverse engineering, you should absolutely give this a try. It makes you want to go out to the dollar store, buy a cheap BLE device, and see what it's doing on the inside.
One of the biggest problems in robotics is precision, and there are so many reasons for that, but one is just getting motors that reliably go where you need them to go at the speed that you need them to get there, and allow your any kind of software, PID loop or otherwise, to have an effect and control over that. That's why when you see people build robots out of servo motors, like a robot arm, you just assume it's going to be kind of crappy. Let's be honest about it.
They're super jumpy, super janky.
Yeah. And so, it's hard. Like the kinematics that you do for acceleration, deceleration can be tough, but that physical part of building it is what separates a lot of the really high-end, NASA grade robotics or Boston Dynamics grade robotics from what you're doing at home. We've seen great examples of people that have gotten around that, and a lot of it is like building your own motors. But this one is especially awesome because Adam Bachstrom took some relatively easy to acquire hobby servos. I guess it's belittling to call them hobby servos, but they're just little servo motors.
No, it's absolutely not. The ones he's using in the front arm of this, the three front ones, are dollar servos if you get them from China. It is not belittling them. You can't belittle the MG90. It's as little as it gets.
Yeah, but that one's got the metal gears in it, right?
Yeah, but again, $1 from Alibaba.
I usually say hobby servo, and I'm talking about those ones that have like the plastic gears in them and they're always stripped down and are awful. But look, these are not that much better. You're right.
This is a piece of work. Carry on, though.
Go watch this video and you'll see the amazing, those mechanical pencils that have the sticks of lead in them?
Yeah.
He takes one of those and puts it in the robot arm and twirls it all around and moves it in special patterns. And then there's an upturned tip of another mechanical pencil, and the robot arm lowers this inch of lead sticking out into the upturned stationary tip, which you just assume it's going to break that thing off because any kind of little rattle or other motion that you weren't expecting is going to immediately snap that thing. And so that's a really cool demo, first of all. But the way he did it is a combination of magnetic encoder on the motor, which totally makes sense, but also a custom motor position sensor that's built right inside of them, not just the servo motor, but the DC motor that is inside of the servo motor.
Yeah, and this is the part that had me scratching my head for a little bit. Like, basically, he also takes the brains out of the servo and replaces it with a microcontroller. So he is kind of rebuilding these servos to make them a lot better, but with cheap and easily available stuff. So, kudos. And this little sensor, did you want to talk about the sensor on the inside of the motor?
I think we're going to talk about the same thing. Like the encoder wheel for this sensor is just a white circle the size of the motor itself, and then a black circle that's off center from it. And I looked at that for a long time and cannot figure out how that has any usable resolution.
There's a gear train in between the motor and the position of the thing. And so that can turn, I don't know what it is, 50 times for one turn of the other. But he's also got photodiodes in there. They're like photoreflector diodes. There's an LED in there that shoots light out and it gets received by a phototransistor. He's running these in analog mode. So when the white one is like half reflecting because it's like halfway around, when the wobbly white disk is fully reflecting white in one of the two sensors, he can tell that way. And so he's actually got kind of analog position sensing on not just one, but two. So he can also do quadrature. And that's downstream by the gearbox of the part that's actually moving around.
I'm glad you looked that up because I was wondering if they were running analog, but then these are phototransistors. So is there some kind of like saturation mode that can be measured in these?
Yeah, I'm sure there is. And I mean, he picks some resistor values, and I bet he's picked them so that they sit right in the middle of their range because, well, you would.
Right, but if your point that there's a gearbox involved. So when I started looking at this and I couldn't quite come up with it from his write-up, I figured, that motor is spinning so fast compared to the geared down output. Right. You don't need that much resolution on this because you have the magnetic resolution for the output.
Yeah, exactly.
The combination of these two he's using to get rid of any backlash that would be expected in the motor. And boy, it sure works.
Yeah, and this is the part that blew my mind. It's worth saying that this is a year-long project of Adam's now, and he says that he's been messing around with trying to get better accuracy out of servo motors for like 15 years. But he started on this project just recently. And you should go check out his GitHub. He links it in there, and it's got a lot more of the nitty-gritty of how this works. But this is a masterful reworking of these cheap motors. It makes awesome robotics cheap.
Now I need to go buy some servo motors.
Dude, you just pull some out of my closet over there. Those MG90s, I got them up the wazoo. I have some bigger ones that I really need to do something with. All right, last up is a video from Integza. He makes some pretty funny ones. He's been playing around with rockets and vortex rockets, and this one is, I guess it can't be the last step in this project to make a 3D printed vortex-cooled rocket, because this one needs to stop leaking. First off, a vortex rocket swirls the things that are going to combust into the combustion chamber in such a way that they mix and only light on fire in the middle. The idea is that it will keep the walls of whatever's containing this from melting and exploding. So then you could think, well, maybe I could get away with a 3D print here. He's tried that before, but then his nozzles end up melting, even though he manages to not get the chamber to do so. So the question here is, how can he make a nozzle to go along with the system so that he can make his own jet engines and 3D print them? An honorable goal. This one, he uses a photolithography printer, one of those resin printers, except he's got a resin that also has some ceramic in it. And the gimmick with this is that after you've printed it, you can then take the 3D print out, throw it in a kiln, sinter it down, and then you've got a ceramic part that's then heat-proof enough to hold up to the jet engine. The only problems that remain are how to make it then airtight, pressure-tight, dimensionally tolerant, and how to keep the whole thing from lighting on fire.
Those are a lot of problems to solve, Elliot.
Did you watch the video?
I did. This video is completely ridiculous in that...
It's completely ridiculous.
The number of things that don't go right is myriad.
Yeah, but, He's making a rocket engine, man.
I just, when he goes to clean up the support material on the ceramic parts that he's baked, I'm like, this is not the way.
Yeah, this is the problem, is that the 3D printing sounds really easy, and you're like, oh man, I'd hate to do the modeling for this. This is going to be so tedious. I'll spend 4 hours, at my computer doing the CAD modeling for this. You're going to spend 4 hours just clipping those little supports off of the 3D print as well.
It is interesting to see, like, cracks are a huge problem with the 3D printed ceramics for him. And he prints a bunch of tests to see which gets the fewest cracks. And then the thing leaks like crazy from the part itself and ends up needing all kinds of coating. I'm just wondering if the molding, 3D print the mold, then mold the ceramics wouldn't have been a better route for him.
Yeah, and once you start doing that, then you want to do it in aluminum. And, you can go down the rabbit hole on that one.
Yeah.
And, you could take that to extremes, I think. I know what you mean. And the problem is, of course, that these 3D ceramic resins aren't 100% ceramic, right? So when you kiln fire it, that plastic just kind of melts off and goes away. And so you've kind of naturally got holes in them. He tries to fix this by adding extra cement or gasket compound or extra slip. He tries a bunch of things to seal these up, mix them together. He gets some pretty decent success, and he gets some motors that, they fire off real jets and make a significant amount of noise before they catch on fire and break. So, mixed success, but you do get the feeling that he's getting somewhere. And the other thing that I thought was really cool about this is that once you're 3D printing these structures and you don't have to put them in a mold like Mike and I were naively suggesting, you can use all sorts of funny surface features to make them stronger for their weight. And he uses iso grids here, which are really cool. It just looks awesome. It's ribs on the outside of the rocket cylinder that are all triangle shaped. And so it's like putting struts all around the outside of the thing and building them in. So it makes it really strong and stiff for how much it weighs. And this is like super high technology that you can do yourself through the wonders of 3D printing. It's just you have to clip all the support off of it.
First up on my list of quick hacks is a project after my own heart. Eric Steiger, who is the person behind MCU on Eclipse blog, has built yet another clock made of analog clocks. This one is an 8x3 grid of these clocks, and the special part of it is the hands of the analog clock are light pipes, and all around the outside ring of the clock, you can't see it because it's covered by the bezel, but there are LEDs and the choice of RGB LEDs. And so you can change the color of the clock hands, which is really cool. There's also one that I hadn't noticed him doing before in here, which is having one of the hands which reaches the entire diameter of the clock instead of just the radius like you'd normally have. I also just love, every time I see him build one of these, I look at the motors that go into these. It's a 2-axis dashboard motor from Automotive, and someday I'm going to buy one of those. Next up, another wonderful display that comes out of Breakfast NY. This is a flip dot display, but normally you'd see all of the dots be like yellow or white on one side and black on the other. In this case, the one side of all the dots is a photo mosaic, and then the other side of all the dots is a differently colored photo mosaic. And so you could still use it kind of as a display. When you do flip some of the dots and not all of them, it merges together the two pictures, and it's a really clever take on the technology. And finally, we have a really low-level lab experiment. This comes from Hackaday alum Nava Whitford, and it is a way of measuring the concentration of particles in a solution. It uses the Coulter effect, which is putting an anode and cathode into either end of a solution and then putting a divider between them with a tiny, tiny hole called a nanopore in it. And every time a particle passes through that nanopore, it will stop the conductivity for just a little bit, and you can actually measure that and then run it through this equation to tell the concentration of particles in that solution.
All right, my quick hacks 3 this week are 4, because I've got 2 aluminum foil speaker hacks that I'm going to talk about as if they were one. Ha ha ha. Coming off first, a hi-fi speaker from some foil and magnets. This is JGJ Matt's project. It's basically like those foil ribbon microphones that we've showed off a week before, done in reverse, turning it into a speaker. This is just a beautiful build. You crimple some aluminum foil by running it through a 3D printed jig, run your audio signal through it, and the current induces a magnetic field, makes the aluminum foil wobble, and you get a speaker out of it. Jan Derogi, on the other hand, had some cylinder phonograph records and needed to make that little reading head, which in that case is called a reproducer. Where's the aluminum connection here? He uses a circularly stamped wiggle pattern in an aluminum disc and then pulls his own glass stylus needle, fixes it in there, and uses this to listen to ancient cylinder phonograph records. It's a beautiful hands-on video showing how he does it all. And next is Cursed USB-C, when plug orientation matters. This is a super demo by Pim de Groot about the weird idiosyncrasy of USB-C, that it is reversible. You can plug it in one way or the other way, and it shouldn't matter, except on the inside, they all go to different wires. And he makes a lovely device that lights up LEDs one color when you plug it in right side up, and it lights them a different color when you plug it in upside down, just to show you that there's magic going on the inside. And last up, Arduino serial versus serial USB. Speaking of debunking magic, Andrew looks into this one. It turns out that if you run an Arduino that has a USB to serial port converter on it, it will spit out data across to your computer slower than one of the Arduinos that emulates the USB directly on board and uses the serial USB command. I guess this is actually no surprise, because one of them you're actually speaking 9600 baud to a converter chip, and the other you're just talking directly USB to your computer. What surprised me here, though, is that when you tell the direct USB serial command that you want it to be 9600 baud, it completely ignores whatever you say and sends the data as fast as it can across. That's what he finds out and investigates in this video.
It's time for our Can't Miss Articles of the Week. This is long-form content written by excellent Hackaday writing staff, and Lewin Day is up this week with how laser headlights work. But Elliot, we have to talk about this art before we get too into the article.
Zap, zap.
I don't
Pew,
know
pew.
how Joe Kim does it, but his ability to tell a story in one frame illustration is amazing. So did you notice? So there's a car in this illustration, and out of the headlights, some red lasers are shooting. But did you notice what's over on the right of this image?
It's cutting something in half. What is that? A speed limit
it's like
sign
a
or something?
Speed limit sign, yeah. Is in silhouette, like out of focus in the foreground, is being cut in half by these lasers as the car looks kind of anguished at what it's done. But the nice thing is these headlights are not shooting lasers out of them. That is not how they work. These headlights are actually, I think they're doing what white LEDs do, right? There aren't really white LEDs.
Exactly.
There are blue LEDs that have yellow phosphor in front of them. And when the light wavelengths from the blue LEDs hit the yellow phosphors, the phosphors excite and they emit a spectrum that is white.
Exactly.
So in this case, with these headlights, you have a yellow phosphor that's being excited by a blue laser. Because lasers are better than LEDs, right? Everyone knows that.
I've actually got a projector for my computer. It's an old Casio A whatever that uses blue lasers to do its light source as well. And it's got a rotating little phosphor disc in there that has a gap in it. So when the gap passes through, it shines the blue laser straight. And when the gap isn't there, when it hits the phosphors, it re-radiates green. So it actually does blue and green off of one blue laser by doing something very similar to this phosphor trick. And then it's just got a big honking red LED for the red channel.
The article here talks about the why, right? Why are we doing this? And I kind of wondered the same thing, and there are a few really good reasons for that. First of all, the efficiency is a lot better. These things are hard to really nail down exactly where the numbers are coming from, but I did find a slide deck presentation up on the Department of Energy's website from a few years ago that BMW made when they were developing these headlights, where they're touting 300 lumens per watt, which is a 55 to 75% efficiency when doing this with the laser, which is fantastic because I also found a 2014 report that talked about the LED efficiency being about 130 to 150 lumens. So you're talking about at least twice the efficiency. And for vehicles that are running off of batteries and want to stretch their mileage, if you're driving all night with your headlights on, which the LEDs, they're efficient, but not nearly as efficient as the laser. And if you look at like halogen, so that laser was 300 lumens per watt. The halogen bulbs are coming in more like 25 lumens per watt.
Right, and that's where I think the lasers really shine. Lasers, they don't really want to be driven hot, but they don't mind nearly as much as LEDs. So you can put more current through a laser and get more light out than you can with an LED. And so these also let the whole thing be a little bit smaller, I guess. Then they have to figure out how to cool it off, and they have to figure out how to make it safe, and it's tricky.
Well, that cooling is an interesting part of it. So this is like a big look into how complex automotive lighting has become. Because, it used to just be a big honking glass bulb that you would, put in there and then clip a thing onto the back and you were done. But now these have like active cooling in them. There's a video included in this. Mike's Electric Stuff, a great friend of Hackaday, did a wonderful teardown video on a BMW array that he was able to get on the secondhand market. It had been cracked and wasn't usable anymore. And then also on some AliExpress bulbs that are not branded, so they're off-brand. And some of these have like mechanical baffles in them. So there's like a reflective baffle that swings out of the way
right
when you want to go from high beam to low beam and back, which is just incredible. And on these lights, they're not only laser at this point, they also have LEDs in them. So like your regular running lights and even your low beams, it looks like, are going to be LEDs. And then the high beams that you're going to try and get a much further distance out of are going to be using the lasers. And the power density of those LEDs is mind-blowing. Like, he takes this apart and puts a piece of paper in front of the LED and turns it on, and it burns a hole in the paper.
Yeah, exactly. Yeah, LEDs are no joke either. It always surprises me that they don't just burn a hole through these phosphors. But I guess the phosphors are picked so that they shed as much of the energy away in the form of light as they can. But like, why those things don't catch on fire, I don't know.
He does mention that on one of the designs, there's a metal arm that is in front of the diode. Like, there are failure modes built into these so that you will never have an unrestricted laser diode just shooting out the front of the car, even in an event of like a car crash. There are, multiple electronic monitors on it. So if it still has power to it and something's not working right, those should kill it, which are interesting. Whoa, I gotta say, looking at the ability to sandwich these bulbs into a smaller and smaller space and have higher and higher efficiency and better illumination, like, it is just constraints from all sides.
I have to say, there is no problem that BMW won't solve with more technology. And that includes problems that don't even exist. They will make up problems and solve them by throwing crazy technology at them. And no surprises coming out of the Beamers. My choice this week was Tom Nardi's Hey Google, Is My Heart Still Beating? This is a look into a university research project to see if smart speakers can be used to tell how a person's heartbeat is doing. And in particular, they're looking at figuring out if your heart is beating regularly or if you have some kind of arrhythmia. The cool thing here, for me anyway, is not so much the medical, but the way it works. And that is they're using an ultrasound speaker, shooting that out at you, and then using the beamforming abilities of a smart device-like array of MEMS microphones the reflected sound coming off of your chest to detect how far your chest is moving, and then they're using that to infer your heartbeat. And it's really crazy that you can figure out how the heart is beating in your chest from the resulting like half millimeter motion that your chest cavity makes when it beats. And it's even more crazy that they can do that when you figure that they're trying to do this with ultrasound, which has like a longer wavelength in air than this half millimeter they're trying to detect. So there's some really deep math here and a lot of heavy signal processing. And let's be frank, it's also done in super controlled situations.
And it's not stock, right? You don't just buy an Amazon Echo and then do this experiment.
Yeah, so that's the other thing. They kind of sell this as being something you could do with devices that are already in your home. But what they've really got is a speaker that points directly at you. And that actually turns out to be important. So you can't just have your Amazon Echo sitting there. You have to have it sitting there with the speaker pointing at you. And you do have to kind of be in the, 1 foot, 2 foot range away from it. So again, this isn't something that you're going to do with the dot that's sitting over there on your shelf. But nonetheless, this is a great proof of concept for a kind of medical diagnostic device that has non-contact and fairly decent resolution from the look of it, and can be made with kind of consumer parts that are being mass produced for other consumer devices. So even if they're not going to like hack open Echoes using that hack we talked about at the beginning of the show, I think they can use kind of that same technology to bootstrap into a cheaper medical device, maybe. I don't know.
To help people age in place and to give them peace of mind that they have some feedback on how they're feeling and that sort of thing. Like, this is a really interesting thing to study. I don't think it's as big of a problem that it's in a controlled situation, because you can find controlled situations like that in the home. For instance, like having a sensor in front of the bathroom mirror so that when you stand there and brush your teeth, it could be, recording your heartbeat for a few seconds.
That's a good one.
And logging that down. So it does have uses there, and I totally think this should be studied. For this particular heart arrhythmia thing, though, it's just so easy to get a consumer-grade smartwatch and do this right now.
Yeah, if that's the competition, and you can have a watch on your wrist all day, and that's fairly unobtrusive versus, this only works when you're standing in front of the magic mirror in your bathroom. I think you're right. I'm sold on that angle of it for heart health. Oh man, I love their technology so much.
Yeah, no, I like the thing is, you have to study this stuff. Like, you have to come up with a reason to study this stuff. And if you think that it's not the greatest application for this particular problem, then you're never going to discover anything new, right? You're never going to try anything. So it's definitely worth studying. And I think that their results are very interesting. It makes me wonder where it will go. I think we talked earlier this week about, smart devices that have sensors built into it that aren't actually being used. And so you could see at some point that the kind of sensors that they're using for this, the ultrasonic range finding, could end up being in these devices for one reason or another. So having this already out there, or this could end up being like another reason for it. Like, you don't discover things by not trying stuff that doesn't make sense. You discover things by, hacking around on it and then having, the killer application just pop up through, chance.
What I want to see coming out of this is some of our crew, some of the hacker types working on this. Because what's really neat about these microphone arrays, and Tom links to the one they used in this project, which actually turns out to be an over-the-counter, hacker-friendly $125 microphone array. What's neat about these is that then you can buy that thing and it'll do the beamforming, so you can kind of sweep around you in software and get this 360-degree sonar ping off of it. And I think that's really interesting. But we talked about that Alexa hack at the top of the show here, and I wonder how much a used Alexa goes for on eBay, because that's a great source of microphone arrays. And if you can just flash new Linux operating system in there, I want one of these on my little robot.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you see something cool, please let us know about it. tips@hackaday.com. And until next time,
keep on hacking. Oh, who did that? Okay, now for real.
Now for real?
First off, a vertex... Blah.
Yoo-hoo! Quick hacks!
Ooh, super explanation.
Hopefully it was right.
First, that was a lousy intro. You all set?
I'm all set.
I'm all set.
You can email us. Oh, no, you can leave a comment, Elliot.
Hey, you can email me too.